Today we're going to continue with analyzing displacement versus time graph to calculate velocity and also acceleration. Alright, so now we are given displacement versus time graph here. And if we look at the graph here, we can see that the graph have three different stages: AB, BC, and CD. To calculate the velocity for the graph, we need to calculate the gradient. As you can see here, the gradient from 0 second to 6 second is 1 meter per second. And the gradient from 6 second to 12 second is 0 meter per second. And the velocity or the gradient from 12 second to 20 second is 0.5 meter per second. So now we're going to sketch the VT graph for the ST graph. Remember, velocity from AB is 1 meter per second, BC is 0 meter per second, and CD is 0.5 meter per second. To sketch the VT graph, you need to sketch the exact same time axis, meaning to say you need to know all the important time here, which is 0 second, 6 second, 12 second, and 20 second, because this would be the point where your motion changes. So here I have my velocity versus time graph. And if you notice here, I have plotted my 6 and 12 and 20 second on my time axis. From 0 second to 6 second, the velocity was 1 meter per second. And from 6 to 12 second, the velocity was 0 meter per second. And from 12 to 20 second, the velocity was 0.5 meter per second. So this is my velocity versus time graph. So now let's look at the next example. Figure 2.26 shows the velocity versus time graph that is plotted based on the linear motion of car driven by Encik Kasim. He drives his car at a speed of 30 meters per second and applies the brakes when he sees an obstruction on the road. Interpret the velocity versus time graph of the motion of his car and sketch displacement versus time graph and also acceleration versus time graph. Now, for VT graph, remember, the gradient for VT graph represent acceleration and the area under the graph represent displacement. So now let's sketch the ST graph based on the following VT graph. When we want to calculate ST graph, when we want to sketch ST graph, we need to know the area under the graph. So here, I'm calculating the area under the graph. The area for A1 here is 180 meter. My A2 is 60 meter. And the total displacement is 240 meter. Again, we're going to sketch the exact same time axis. So if you look at my time axis here, I have sketched or I have plotted my 6 and 12 second because this is where my motion starts to change. What was the displacement covered in 0 to 6 second? It was 180 meter. So I'm going to plot my 180 meter And do not forget to draw a dotted line to show that it is 180 meter. Now, what is the pattern for the graph? Is it increasing linearly or is it increasing exponentially? Meaning to say, is it a curved graph? Now, if you look at the graph here, the gradient is 0. Alright, meaning the velocity is constant. Since the velocity is constant, I know that my graph is increasing linearly because the gradient for this graph is constant. Next, we're going to plot what's happening from 6 seconds to 10 seconds. Now, what was the total displacement covered in 6 to 10 seconds? It was 240 meter. So what is the pattern for the graph? If you look at the velocity versus time graph, the velocity was decreasing and it has a negative gradient. Now remember, it means the object is still moving, but it is slowing down. So my graph is going to look like this. It has reached 240 meter, but then with a decreasing rate. So my graph is going to be curvy and it's actually concaving down. Now we're going to sketch the AT graph or the acceleration versus time graph. Remember, to calculate the acceleration, we need to calculate the gradient. So the gradient from 0 second to 6 second is 0, meaning the object is moving with a constant velocity. And the gradient from 6 second to 10 second is negative 7.5 meter per second square, which means the object is slowing down. Then I'm going to plot my acceleration versus time graph. The acceleration was 0 meter per second square from 0 second to 6 second, and the acceleration was negative 7.5 meter per second square from 6 to 10 second. When you want to sketch a graph, all these dotted lines you need to include in your sketches. So now let's try this next example. Interpret the velocity versus time graph and sketch a graph of displacement against time and also acceleration against time. So now let us sketch the displacement versus time graph. Remember, when you want to sketch displacement versus time graph, you need to know the area under the graph. So let us calculate the area under the graph for area A, B, and C. The displacement for A is 100 meter and the displacement for area B is 260 meter and the displacement for area C is 160 meter. So the total displacement is 520 meter. This means that the object has moved by 520 meter in 50 seconds. Alright, so previously we have calculated the displacement From 0 second to 10 second, the object has reached 100 meter. Alright, so I'm going to plot my data here. Then from 10 second to 30 second, it has reached another 260 meter. So in total, it has reached 360 meter in 30 seconds. And in 50 seconds, the object has reached a total displacement of 520 meter. Now, remember, when you want to plot the pattern of the graph, you need to refer to your velocity versus time graph. The velocity versus time graph from 0 to 10 seconds is a constant velocity. So your graph will be increasing linearly. And from 10 seconds to 30 seconds, you notice that the velocity is increasing. Since the velocity is increasing, the displacement will be increasing exponentially. That's why you see this section, the graph is concaving up. And from 30 seconds to 50 seconds, the velocity is decreasing. Since the velocity is decreasing, it means the object is moving but with a decreasing rate. And that is why my graph for this section concave down. So now let us sketch the AT graph, or the acceleration versus time graph. Remember, to calculate acceleration, we need to calculate the gradient. So the gradient from 0 second to 10 second is 0. And the gradient from 10 second to 30 second is 0.3 meter per second square. And the gradient from 30 second to 50 second is negative 0.8 meter per second square. So now let us sketch the AT graph with the following information. So this is my acceleration versus time graph. Alright, simply plot the graph with the following information.